When we have the unknown in these three examples, where the unknown here in this first example A, we've got the unknown is C and it's up as an index. Here we've got an unknown F and it's in an index up the top, or a power. And here we've got a third situation where the X is the unknown we're trying to find and it's an index as well. They're called Indicial Equations, and it's a matter of recognising how the equations are presented so that you know which steps and which process you're going to work through to get the answer. So let's go through these one by one. Here we've got 25 to the power of 2c minus 3 equals 5 to the power of 3c minus 1. Now at the moment it's not looking too promising. We've got a different base over here. We've got 25 and we've got 5. So my first inclination is to, let's see if we can make the bases the same. If we can make the bases the same, then the indexes must be the same. So 25 can be expressed, so instead of writing the number 25, I can go 5 to the power of 2. That's the same as 25. Now 25 is raised to this power, so I've got to raise this to this power. Equals 5 to the 3c minus 1. If we cast our mind back to the laws of indexes, when you raise a power to another power, you multiply the indices. So that'll be 5. Now 2 times 2c is 4c, and 2 times negative 3 is negative 6. So we get 4c minus 6 equals 5 to the power of 3c minus 1. We now have the same base. We've got a base 5 and a base 5 on both sides. And if we've got the same base on both sides, then these indexes must be equal. It's the only way that equation would be true. If you've got the same base there, then the indexes must be the same. So our very next line, we can write 4c minus 6 equals 3c minus 1. And as we've done in previous work, we've got c's, or the unknowns, on both sides, and we take them to the side that's got the most positive. So this has got plus 4c, this has only got plus 3c, so we'll take the c's over here. So we get 4c minus 3c, or we take 3c from both sides, and that'll give us 4c minus 3c. And if we're getting the c's on this side, we're going to put the numbers on the right hand side. So we'll add 6, add 6. So we're virtually doing 2 steps in one here. So we've got 4c minus 3c, minus 6 plus 6 is 0, so we don't write any there. 3c minus 3c is 0, minus 1 plus 6 is equal to plus 5, or just equal the number 5. And our next step, 4c minus 3c is 1c or c equals 5. And once again, we should go through and check. Left hand side, we're going to put c equals 5, and we get 25 the power of 2 times 5 minus 3, and that's equal to 25 to the power of 7, which is equal to, now 25 is 5 to the power of 2, so that's 5 to the power of 14. Okay, 25 is 5 to the power of 2, so you've got 5 to the power of 2 to the power of 7, 2 times 7 is 14. Right hand side is equal to 5 to the power of 3, now c we're saying is 5, minus 1, 3 5s are 15, minus 1 is 14, so 5 to the power of 14. So you don't have to work out what they are as numbers. In power notation, index notation is fine. So the answer is c equals 5 to the first one. Okay, let's have a look at the second one here. We've got 4 to the power of f. Now this is not a plus, this is a multiply. 8 to the power of that equals 64. At the moment we can't multiply those two together, we can't add their indexes because they've got a different base. We've got base 4 and base 8, And over here we've just got the number 64 by itself. Now something's telling me that if we make everything base 2, we're going to use a similar type of process to over here. That can be made into base 2, that can be made into base 2, and that can be made into base 2. So 4 is 2 to the power of 2, and that's got to be all raised to the power of f. 8 is 2 to the power of 3, and that's all to the power of 2f minus 6, equals 64. 64, if you don't know your powers of 2, you can write 64 down, and then just keep dividing by 2 until we know 2 is going to go into it because it ends in an even number. So that'll go 32, 2 into 32 goes 16, 2 into 16 goes 8, 2 into 8, 4, and 2 into 4, 2, and 2 into 2, 1. You keep going until you get 1 down there. And how many 2's we've got? 1, 2, 3, 4, 5, 6. So that'll be 2 to the power of 6 is equal to 64. Looking good because we've got base 2 now all the way through. So let's just simplify these and remove these brackets. We go a power to a power, so we've got 2 to the power of 2f. 2 times f is 2f. Times 2 to the power of, now it's 3 times 2f minus 6. So you've got to multiply 3 times the 2f and you get 6f. The minus comes down from the minus 6 there, and 3 times 6 is 18. Equals 2 to the power of 6. Now, because we're multiplying like bases, let's do it in red to show we've got 2 there, 2 there. So because we're multiplying, we can add the indexes. So we get 2 to the power of, now 2f plus 6f is 8f minus 18 equals 2 to the power of 6. Just like over there, because the bases are the same, the indexes are the same in part A over there. Over here we're doing the same thing. We've got base 2, base 2. So therefore the indexes can be equated to each other. So we've got 8f minus 18 equals 6. Here is my unknown. We want to get that by itself, so we're going to get rid of that minus 18. So we add 18 to both sides. They will cancel each other and you get 8f, that'll be 0. 6 plus 18 is 24. Divide by 8, divide by 8, and that'll get you with f by itself. 8 into 24 goes 3. Once again, you should check left-hand side equals and right-hand side equals. So just for economy, I'll let you do that. So substitute f equals 3. And we should be able to work something out there, and then hopefully it'll be equal to 64 because the right hand side is 64. But don't force it, just put f equals 3, work that out on your calculator, and away you go. Alright, this one's not so easy. We've got numbers all over the place here, and really it's a type of question that you just need to be able to recognise. We can't combine these two together. We can't combine anything together. I'm thinking that we could get things to base 2 here. And so we've got 2 to the power of 2, all raised to the power of x. 2 to the power of 2 is 4. Minus 16. Now there's a multiply understood before that bracket, 2 to the power of x. And I'll bring the minus 64 over the other side to make it, I'll just add 64 to both sides. And that'll give us 0 on the other side. Now 2 to the power of 2 all raised to the x is 2 to the 2x. So I can actually swap those two around and do that, because that's still 2 to the power of 2x. So this is 2 to the power of 2x, multiply those two together. This is 2 to the power of 2x, but I'm doing this for a reason. Minus 16 2 to the power of x plus 64 equals 0. The reason I'm doing this is that this looks to me like it is a quadratic. It's something squared. Here's my ax squared minus bx plus c. Here is my term that is the quadratic. So to make it look a bit better, I'll introduce another letter. So let's just use capital Y. I could use any letter I like. I'm just going to use capital Y. Let y equals to the power of x. It'll just make it easier working. So instead of 2 to the x, I'm going to write y. And so I get y squared minus 16y plus 64 equals 0. Now hopefully you can see that that is a quadratic. Quadratic has the highest power of a square. And we've got a couple of methods for solving quadratics. We've got the quadratic formula, but I'm thinking this might factorise. So I'll use the cross method. I've got y and y because y times y gives me that first term. This positive tells me these two signs are exactly the same. So they could be both positive or both negative, because when I multiply on there, I'm going to get positive 64. Now, when I multiply along the arms and add, I've got to get minus 16y. So I'm thinking if I go minus 8, when I multiply along those, I get positive 64. But when I multiply along the arms, and you can multiply along either arm first, so there, minus 8y. That arm, minus 8y. You always add these two together, and you're hoping you're going to get the middle term up here. So minus 8y plus minus 8y is minus 16y. So yes, we get minus 16y, so that is the correct factorisation. So we get y minus 8 times y minus 8 equals 0. Well, where does that get us? So you know by the null factor theorem that either this must be 0 or that, but they're the same thing. So y minus 8 equals 0. There's the only way you're going to get 0 is if one of these is equal to 0, and they're both the same, so you only have to do one of these. So y minus 8 equals 0, add 8 to both sides, and you get y equals 8, positive 8. Okay, but we were asked to solve for x up in this original line. We were the ones who introduced the y up in this step up here. So what we've got to do is do what's called the back substitution. Instead of y now, I'm going to put 2 to the x. So 2 to the x equals 8. 8 can be expressed as 2 to the power of 3. We've got the same base, so the powers must be the same. So x is equal to 3. And finally, that is the answer, x equals 3. We should go through and check. So the left-hand side equals x equals 3, so that's 4 to the power of 3 minus 16 to the power of 3. And that is equal to 4, 4, 16, 64 minus 8 times 16 is 128. 64 minus 128 is negative 64. And the right hand side equals negative 64. So we know that our x equals, so the answer is x equals 3. So 3 very different indicial equations. You need to recognise which, this one is a special one, I suppose, this C. It's the hardest one I think you're going to find. These ones here on A and B, virtually your tactic is to try and get the same bases on either side, and then you can drop those bases as we did here, base 2, over here, base 5. Okie dokes.